Okay, this is grade 9. One lesson here. Well, it's lesson 1 and 2. It's 6.1 to 6.2. We're going to talk about solving equations. So this may seem like a weird example, but this is a great way to teach about equations. For instance, if you have a flat tire, right, you can talk about the different steps of changing that flat tire. You position the jack, you loosen the lug nuts right on the tire, you jack up the car, you remove the lug nuts, and then you remove the flat tire. It's pretty basic. Now, to put a tire back on, basically all you do is you take these 5 steps and you reverse them, right? You put on the spare, you put on the lug nuts, you lower the car, you tighten the nuts, and you remove the jack. Well, that's all algebra is. It's doing the opposite of what it is. It's like the undo function on any Word document or anything you've done on the computer. You can hit undo and it reverses it. So for instance, if we're talking about subtraction, the opposite of it is addition, or the inverse. Multiplication, the opposite is division, right? So you can do all that to help you solve for an unknown variable. Okay, so flip the page and look at the first example here. So what we got is we want to solve for x. And you want to get x by itself. That's the key. Always try to get x by itself. So what we do is we have x plus 2.4 equals 6.5. Well, what's the opposite of adding 2.4? Well, subtracting 2.4. And if you subtract 2.4 from one side, you subtract 2.4 from the other. So then we do that and we end up with x equals 4.1. Well, how do you know that's the right answer? Well, you can check. You can plug it back into the original equation. So look at your left side here and look at your right side here. So all we do is we replace x with 4.1. We add them together, we get 6.5 on both sides. And you can see right away, oh yeah, that works. Okay, let's look at number 2 here. Sometimes you'll get it in words. Okay, 3 times a number is 3.6. 3 times a number, so 3 times a number, which is your variable, there's your equals 3.6. Well, again, the same rules apply. We're trying to get x by itself. So x is not by itself. There's a 3 attached to it, and the 3 is attached by multiplication. Well, how do you get rid of it? You divide both sides by 3. Divide and divide. So these 3's reduce down here, and you get 3.6 divided by 3, which is 1.2. And again, you can check your answer. Plug 1.2 back into the original equation and see if you get that. Okay, example number 3. A number n, use any variable you want, right? You don't always have to use x, is divided by 4 is 1.5. So n divided by 4 equals 1.5. Okay, so it's n divided by 4. What's the opposite of doing that? Well, multiplying by 4. So we put the 4 up here. Now, we normally put the 4 up on the left-hand side. If you put it on the right-hand side, it looks like an exponent, so you really don't want that. You want to have it on the left here. Okay, so the 4 is reduced down here, and then we end up with 4 times 1.5 is 6. And again, you can check your answer by plugging it back into the original function. Okay, go over to next page and go to example number 4. Now, this is an interesting way of doing it. So you can do, there's another way of doing this. So it's 4.5d plus 8.5 equals 18.5. Now, in this one, we have 2 steps. We still have to get d by itself. So the first thing we do is, let's subtract 8.5 from both sides, because the opposite of addition is subtraction. So then we end up with 4.5d equals negative 27. Then 4.5 is multiplied by d, so we divide both sides by 4.5 when we end up with d equals negative 6. Now, some people have a really hard time knowing the order to do stuff. So what you can do is you can do something over here on the left, the story of d. What happened to d? So look at d. Oh, the first thing that happened to d is it was multiplied by 4.5. There it is there. And the opposite of that is divided by 4.5. Then we added 8.5 to it. So there it is there. We added 8.5, so the opposite is subtracting 8.5. Now, this tells us the order to do stuff. Okay, we start at the bottom here. We subtract 8.5 from both sides, and then we divide by 4.5, which is what we did over here on the right. So that's just the story of d. You can use that if you're really struggling with the order of solving. Okay, let's look at example 5. Solve for r. Okay, now r is not by itself. It's got a 4 attached to it, and it's got a 3 attached to it. Okay, so the first thing we're going to do is we're going to subtract 3 from both sides. Subtract 3, subtract 3. So we end up with r over 4 equals 4.2. Now, r is still not by itself. It's divided by 4, so we got to multiply both sides by 4. And again, we're putting it on the left up here, so it doesn't look like an exponent. So we multiply both sides by 4, we get 16.8. Hey, can you check your answer? Well, of course you can. Plug it back into the original. All right, let's look at example 6. And if you notice, these are getting harder and harder all the time, but the concept is still the same. So example number 6, solve for x. Whoa, this is interesting. We have x's on the left and we have x's on the right. So we have to basically collect like terms, kind of like we talked about before. So let's move this negative 5x over to the other side. Now, we're moving the whole negative 5x, just not the negative 5. So negative 5x, the opposite of that is adding 5x. So we add 5x to both sides. Now, these two over here cancel because we end up with a 0. And then we end up with 7x and 5x is 12x. So we have 12x plus 3 equals negative 15. Good. Now we can go back and do what we were doing before. We have positive 3, so we subtract 3 from both sides. So we end up with 12x equals negative 18. Oh, x is still not by itself. There's a 12 attached to it by multiplication. So we divide both sides by 12. And then we end up with negative 1.5. Now, you want to check your answer? Plug it back in, see if the left side equals the right side. Okay, let's go to example number 7. Now, what we have here is we have the x and minus the 7 in brackets. So we have to use the distributive property. So basically what that means is that 5 has to be multiplied by the x, and that 5 has to be multiplied by the negative 7. You can see right there. So what we do is we do that. So 5 times x is 5x. 5 times negative 7 is negative 35. So we end up with 5x minus 35 equals negative 15. And then go about the same method. You got negative 35. The opposite is adding 35 to both sides. Right, these cancel out here. We end up with 5x equals 20. X is still not by itself. There's a 5 attached to it by multiplication. So we divide both sides by 5, and we see x equals 4. Again, you can check your answer by plugging it in. Example number 8. Ooh, this is more complex. Lots of stuff, but the rules are still there. First off, let's get rid of the brackets. So we're going to distribute the 2 to both things in the bracket. So 2 times x is 2x. 2 times negative 3 is negative 6. Our negative 5 is still there. Our 13 is there, and our minus 4x. Now we're going to collect like terms. So let's take this negative 4x. Let's add 4x to both sides because that'll cancel out over here. So 2x and 4x, yeah. What did we do with the negative 6 minus 5? Well, we just combine them together. We end up with negative 11. So we end up with 6x minus 11 equals 13. Okay, well, how do we move the negative 11? We add 11 to both sides right there. And we end up with 6x equals 24. And to get x by itself, we divide both sides by 6. So we end up with x equals 4. You can see the pattern is the same over and over and over again, even though they start to get more complex. Okay, now here's a really interesting one. And this concept will apply into grade 10, 11, and 12. Oh, it's a bunch of fractions. Oh my goodness, I don't like working with fractions. So what we can do is we can actually get rid of the fractions. Now, if you look, you got a 6 in the, a 3 in the denominator here, a 2, and a 6. Well, what's a common denominator for all of those? Well, that would be 6, right? 3 goes into 6, 2 goes into 6, 6 goes into 6. So what we can do is we can take 6 and take every single term and multiply it by 6. Oh, look up here. We're putting it up the top here. We're multiplying by 6. And what is that going to do? It's going to get rid of the fractions. Easy to figure this out. So look at this. 6 times 2, right, is 12. Divided by 3 is 4. So we got 4x here. Look over here. 6 times 1, 6, divided by 2 is 3. Well, that works. And 6 times 7 is 42. Divided by 6 is 7. Now, you can do it that way, but you can also realize you can reduce, like 6 and 6 reduce down to 1, so then it would just be a 7. Or 2 goes into 6 3 times, so 3 times 1 is 3. Right? You can work through it that way. So we end up with 4x plus 3 equals 7. Now, this is a basic question. How do you get rid of the 3? Well, it's positive 3, so subtract 3 from both sides. These cancel out here. We end up with 4x equals 4, and x needs to be by itself again. 4 is attached to it by multiplication, so we divide both sides by 4. 4 divided by 4 is 1. Hey, can you check your answer? Yeah, plug it back into the original equation and see if the left side equals the right side. Okay, so that is lesson 1 and 2, so 6.1 and 6.2. The next block of it, 6.3, 6.5. We'll see how long it is. It might end up being different parts.